This is the car that we're using for our demonstration, and just to show that it's a toy car, it doesn't have a motor and there's no friction pad on the bottom of it.
Right, for our first demonstration, we're going to roll a car across a rough surface, which is this carpet. You can see that it has a texture to it, and so we're going to see what happens when we roll the car across it. As you can see, it slows and comes to a stop very quickly. That's because an opposite force is opposing its motion. That force is the friction from the rough surface of the carpet. For our second demonstration, we're going to roll the car on the surface of this apparently smooth table and see what happens to its motion. As you can see, it travels a little bit farther than it does on the carpet and moves at a faster rate because of the smooth surface, but it does eventually slow and come to a stop. This leads us to believe that the surface of the table is not completely smooth. Now, if you can see on the edge of the table, there is dust and imperfections and that sort of thing, which are causing the opposite opposing force of friction to act on the car, slowing its motion and causing it to stop. The initial force that sets the car in motion comes from the initial push. If there was no friction or opposing force, the car would continue to travel at a constant speed. This leads us to believe that when a moving object slows and comes to a stop, it's because an opposite opposing force, in this case friction, is acting on it.